Hello and welcome to Lesson 6.6. Today we're going to look at parallel and perpendicular lines. Ultimately, we're going to look and determine whether or not lines are parallel or perpendicular. So to begin with, we're going to look at parallel lines first. And notice we have a red line here and a blue line here, both of which these two lines are parallel to one another. The equation for the red line is written here, and the equation for the blue line is written here. So if you notice between the two equations, and I'd like for you to pause and try to figure out what the difference is between the two, but if you notice, both equations happen to have the same slope. And in this case, that slope, or m, is equal to 1/2. So when you have equations that have the same slope, this tells us that we have parallel lines. So they must have the same slope. Likewise, the other part to this is for them to be two different lines, they must have different y-intercepts. So B1 is not equal to B2. And we'll call the red line B1, and the blue line would be like the second equation, or B2. So your y-intercepts or b values are not the same, but your slopes will be the same if you have two parallel lines. So what this means is that when we have parallel lines, ultimately parallel lines are lines that will never ever ever intersect or cross. They will continue to go on forever, but they will never cross one another. And the reason is because they have the same slope. So they will not be allowed to cross because the slopes are the same. Now, one way you can tell if two lines are parallel, and I would highly suggest that if you're not given an equation in slope-intercept form, that you first write it in slope-intercept. And remember, this is y equals mx plus b. So by definition, slopes of parallel lines says that non-vertical lines are parallel if they have the same slope and different y-intercepts. Okay, so any two vertical lines can also be parallel. So let's go ahead and take a look at a few examples. And the first example says to find the slope of a line parallel to the given line. So ultimately, we have to be able to identify the slope. So in this case, because I'm given y equals mx plus b in this equation here, all I have to do is I have to find the slope of my line. And remember, the slope of my line is the term that is in front of the variable x. So in this case, my slope then is 5. Now for this next equation, I'm going to have to work a little bit more because I need to get it into slope-intercept. Remember, that's y equals mx plus b. So here I'm going to go ahead and subtract 8x from both sides. So this gives me a negative 4y equals a negative 8x plus 12. Then I'm going to have to divide both sides by a negative 4. So when I divide both sides by negative 4, I'm going to end up with y equals negative 8 divided by negative 4 is going to give me a positive 2x. Then I have 12 divided by negative 4 gives me minus 3. So when I ultimately have to find my slope, that tells me that a slope of a line that is parallel to this has to be 2. Now for the next one where it says y equals 3, if you think about the graph of y equals 3, okay, so if I just graph this lightly here, the graph of y equals 3, keep in mind that this is my y-axis, this is my x-axis, so y equals 3 is going to be a horizontal line through the number 3 on the vertical or the y-axis. So remember that the slope of a horizontal line, or m, is going to equal 0. So the slope for a line that is parallel must also be 0. Now for the last one where it says x equals 2, if I graph x equals 2, this is going to look something like x equals 2. I'm going to go to my x-axis. And remember, this is x, this is y. So x equals 2 is going to be a vertical line through x equals 2. And the slope of a vertical line, remember, is going to be undefined. So for me to have a parallel line to that vertical line, the slope must also be undefined or another vertical line. For example 2, it wants us to tell if the lines are parallel with the two equations. Well, for number 1 here, this is done for me pretty much because both equations are in slope-intercept form. So I'm just going to go ahead and look directly at the slope. And because m equals 2 for the top one and m equals 2 for the bottom one, this tells me that yes, they are parallel. Now when I come down to equations set 2, I see the top equation is written in slope-intercept form, but the bottom one is not. So I'm going to write that in slope-intercept. So I'm going to add 6x to both sides. So that gives me 6x minus 24. Then I have to divide both sides by 8. So this gives me y equals, when I divide this out, I have 6x divided by 8, which is going to give me 3x divided by 4. Then I have 24 divided by 8, which is minus 3. So now, when I go and I look at my slopes, I see that for my first equation here, we see that m is equal to 3/4. And then when I come down here to the second equation, I also have a slope that is equal to 3/4. So this is going to tell us that yes, these are parallel. And notice this little symbol here is like a parallel symbol. For part 3, I have my top equation is in slope-intercept, so I can identify my slope as being a -4, and I get that from right here. For my bottom equation, however, I do have to go ahead and get that. So I have 2y equals 4x plus 12. If I divide both sides by 2, this is going to give me y equals 2x plus 6. So here my slope is 2. So this tells me that no, they are not parallel because I have two different slopes. Likewise, for part 4, the top equation is in slope-intercept form, and my slope is -2. My bottom equation, however, I'm going to have to rearrange. So this gives me 2y equals a -4x plus 6. If I divide both sides by 2, I'm left with y equals a -2x plus 3. And here I can see that my slope is also equal to a -2. So then we're going to say, yes, these are parallel. Likewise, when we have perpendicular lines now, okay, so now we're looking at perpendicular lines, you can see that we have our red line right here. The equation for that is a -1/4 x minus 1. We have our blue line, which has the equation y equals 4x plus 2. Okay, without reading the bottom, if you look at the differences between these two equations, you will see that my red line has a slope of a -1/4, while my blue line has a slope of a +4. So if you notice, the relationship between a slope of a -1/4 and a slope of 4 is that these are what we call opposite reciprocals of one another. Okay, so opposite means they have different signs. Notice this one here has a negative, this one down here has a positive, And reciprocals, remember, just means that we flip the number. So I have 1/4, and this is really 4/1. So those are opposite reciprocals. So for two lines to be perpendicular, they must form a right angle or a 90-degree angle here, and their slopes are opposite reciprocals. And again, in order to tell this really quick and easy, make sure that your equation is put into slope-intercept form first. So it says, for example 3 here, find the slope of the line perpendicular to the given line. So what I'm going to do is I'm going to identify my slopes first. So here m is equal to 3, which tells me that m of the perpendicular, and the little symbol that kind of looks like this implies or can be used for perpendicular to show that something's perpendicular. So my perpendicular slope then has to have the opposite sign. So because the slope of my equation is 3, the opposite of that would be a -3, and then the reciprocal of 3 would be 1/3. So that my perpendicular slope then would be a -1/3. Likewise, for this next part, I have a slope of 1/5. So this tells me that my perpendicular slope is going to be equal to the opposite, which in this case would be a negative. And then the reciprocal of 1/5 is just going to be 5/1 or 5. For the next part, my current slope is a -2/3. So when I take the opposite for the perpendicular slope, the opposite of that is going to be a positive, and then the reciprocal of 2/3 is going to be 3/2. So the perpendicular slope is a positive 3/2. And then last but not least, we have our slope of, and now it looks like x divided by a -9. Remember, we can really rewrite that as a -1/9, because this is really a -1/9 times x. And when you multiply fractions, you multiply straight across. So that's our -1x. This is 9 times 1, which is 9. So my slope for this equation is a -1/9, which tells me that my perpendicular slope then has to be the opposite or a positive, and then the reciprocal of 1/9 is going to be 9. So my perpendicular slope then is going to give me a positive 9. So why don't you take a quick second, pause the video, and try to find these slopes out on your own. Okay, the first thing we need to do is we need to write our equations in slope-intercept form, or y equals mx plus b. So when I do that, I end up with 5/7 x minus 12/7. If I want the line that is perpendicular, or the slope of the line that is perpendicular, then I have to take the opposite reciprocal of 5/7. So the opposite of a positive would be a negative, and the reciprocal of 5/7 is going to be 7/5. For the next part, my equation in slope-intercept form is y equals 4x minus 15/2. So the slope of the line that is perpendicular to that is going to be the opposite of 4, and then the reciprocal of 4 would be 1/4. Now the next part might be a little bit tricky, because remember, the slope for a vertical line, and I know it's vertical because it's going through my x-axis, so if I graphed it, it's going to be going through something like this. So this slope is equal to something that is undefined. However, to come up with a perpendicular, the perpendicular means that it has to be going perpendicular or 90 degrees to, and that gives me a horizontal line. So I know that the slope of a perpendicular line then must equal 0. For the next part, I'm going to put it in slope-intercept form, which gives me y equals a -4x minus 9, and that tells me then that my perpendicular slope is going to be the opposite of a negative, which is a positive, and the reciprocal of 4 is 1/4. And then my last equation, I'm given that y equals 5. So again, if I graph this, y equals 5 is going to be a horizontal line. So that means that if I'm going to find the perpendicular, that has to be a vertical line. And the slope then, that is perpendicular to horizontal, is going to be a vertical line. And the slope of a vertical line is undefined. All right, for example 4, it says write an equation for the line that contains the point 5, 1 and is parallel to y equals 3/5 x minus 4. So remember, for parallel lines, we have the same slope. And that means that my slope, in this case, is actually going to be a positive 3/5. So because I know my slope and I'm given this point here, to find the equation of the line that's parallel, I'm going to write my equation in point slope form. So I have y minus 1 equals m, or 3/5, times x minus 5. And now I can go ahead and get y by itself and put it in slope-intercept form. So I have y minus 1 equals 3/5 x minus 3/5 times a negative 5 is going to give me 3. Then I'm going to add 1 to both sides, and I'm left with y equals 3/5 x minus 2. So this is the equation of a line that is parallel to this here, and it also goes through this point. For example 5, however, we want to write an equation that goes through the point 0, negative 2, that is perpendicular to y equals 5x plus 3. So here, my slope is 5. However, I want perpendicular, so I need to find the slope of my perpendicular, and that's going to be the opposite, which would be negative, and the reciprocal of 5 is going to be 1/5. So now I have my slope, I have a point, and I'm going to use point slope form. So I have y plus 2 equals a negative 1/5, and this is going to be x minus 0. So when I simplify this, I have y plus 2 equals a negative 1/5 x. And then to get y by itself, I'm going to subtract. So I have a negative 1/5 x minus 2. And this is the equation of the line that is perpendicular to 5x plus 3, that also goes through the point 0, negative 2. So our last example for today says, a bike path for a new city park will connect the park entrance to the park road. The path will be perpendicular to the park road. We want to write an equation for the line representing the bike path. So ultimately what they're going to be doing is they're going to be connecting our park entrance, which is here, and making it perpendicular to this line right here, which is the park road. And they want to know what the equation is for that. So the first thing we have to do is we have to be able to find the equation, or at a very minimum, the slope of the park road. So I'm going to put the slope of the road. Okay, and you can do that in one of two ways. You can either do rise over run. Okay, like I would pick a point here, and it looks like maybe a point here. And I can see that I'm going up 2. So I'm going, this is my vertical. So I have up 2 and over to the right 1. So I can see that my slope is 2. Or you could have selected those 2 points, and so that I had the coordinate points. It looks like 3, 3, and 2, 1. And you could have found that the slope was 3 minus 1 divided by 3 minus 2, or you get a slope of 2 over 1, which is also 2. Regardless, we know that the slope of our road is 2. So because I know the slope of my road is 2, and I want a slope of my path, so the slope of my path then must equal the opposite reciprocal, so that gives me a negative 1/2. And I know a point on this line, and I'm going to use the park entrance, and the coordinate for that park entrance is going to be 0, 4. Now the reason I'm going to use 0, 4 is because that's my b value. So if I know my slope is a negative 1/2 and I know that my b value is 4, I can just plug my slope in to my y equals mx plus b, so I have negative 1/2 x, and I'm going to plug in my b value or y-intercept as 4, and I can see that the equation of that new path then is going to be y equals a negative 1/2 x plus 4. Now this does conclude the 6-6 video. Please let me know if you have any questions. Otherwise, I'll see you in class.